purpose of all of the mineral properties is really to identify them. All right, so we can look at certain characteristics in each one of these categories, gather information, right, by actually looking at a specimen, right, and determine different characteristics. All right, and then we'll use like data tables and charts and things like that to try to find out the identity of the mineral. All right, so these first three that we're going to talk about, like some of them are really, really good characteristics that are very useful, and other ones not so much, and we'll get into all those. So the first one we're going to talk about is color. Right? What's your favorite color?
Mine's blue, purple, green.
Good. Those are all great colors. So what is color? Right? Like what exactly is that? What makes my shirt blue and yours green, yours pink, and yours black and white? Anybody? Just a guess. What do you think?
Light.
Yeah, right, exactly, the light, right? So if we just have regular, like light, white light, right, that's all wavelengths represented, right? That means that everything is reflected back to your eyes and it looks white. What do you think the color would be if everything is absorbed? Like opposite of white. Would be black, right, exactly. And for certain things like my shirt, right, I've got a lot of the colors absorbed, but what color is reflected back that you see? Wavelength of light. Blue, exactly, and that would be the same for each of the different colors, right? So now let's take a look at some of these. So color, we actually have the definition, and I'm going to go ahead and hold this up. The wavelengths of light reflected, not absorbed by a mineral. All right, so this is one of the physical properties, actually color. All right, so let's go ahead and take a look at some of these examples. What color do we think this one is?
Purple.
Purple, right? Okay. And what color do we think this one is?
Pink, light pink.
Pink, okay. And then let's get to something that may be a little bit more, let's say this one.
Turquoise.
Turquoise.
Green.
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 Green, and I would say aquamarine. Right? And so can we see that there's kind of like an opinion here? Like you can say it's this, and you can say it's that, and you can say it's this color, and I say something different. Right? We had three different colors and three different opinions. So when we talk about color for a mineral, it's actually the least reliable. Right? Because for example, if I take a look at all three of these, right, we've got a pink, right, there's one that's white, and this is kind of like a brownish color. They're actually all the same mineral. Right? So minerals can be different colors, right? Also the same with these three are also the same mineral, right? But they're three different colors, right? And then if we take a look at some of these guys, sometimes a mineral can be multiple colors, right? In one hand sample, all right? So it's probably the easiest one to identify, but it's the least reliable. Right? Because one, we can have a bunch of different opinions about what the color is, and then two, we could have a mineral be a bunch of different colors. All right, are we okay with color? Ready to move on? All right, I'm going to move this guy to the side. This next one here is luster, and I'm just going to go ahead and like read the definition first, and then we'll talk about it. The characteristic of light reflected from the surface of a mineral. The characteristic of light reflected. All right, so what do we think about that? Characteristic of light. Characteristic. So how can, let's put it this way. Besides for color, and if we take a look at like some of these minerals, how else do they look different?
The texture.
Texture, okay, look different. So you get definitely the texture. You can see that they don't all look the same texture, right? What else? What else looks different about some of these?
Shape.
Shape looks different, yeah, you're right. Does maybe, let's say, do you think some of these maybe are a little bit more like shiny than others?
Yeah.
Yeah, right, like which one do you think would be kind of shiny?
This one.
Right, that one, exactly. All right, so then there's one that's kind of shiny, right? Is there another one that maybe isn't so shiny?
Like this one?
Yeah, it's probably maybe a little less shiny than that one. Right? What about this one? Right? Any kind of shine there?
No.
Not really, huh? All right. So kind of luster is how the light is reflected from the mineral. All right? So when we try to identify minerals, we kind of separate minerals into two different categories. We separate them into metallic, right, or non-metallic. So what do you think metallic would be? What do you think it looks like?
Look like a metal.
Yeah, it looks like metal, exactly, right? So pick one out that you think looks like a metal. All right? Any other ones? Yeah, definitely. Now, does metal always look like a silvery color?
No.
No. What other color could it be? Besides for silvery, what other color could metal be? Gray, right? What else could it be?
Gold.
Yeah, it can be like a gold color, exactly, right? And then it could also be like that, kind of that reddish copper color. It can also be, right? So if I was going to first separate these minerals, right, if I was going to separate them in terms of metallic and non-metallic, I would be looking for all the minerals that look like metal, right? And those would be my metallic ones. So I could put this guy over there, this guy over here, this guy, that guy, right? And then the ones that aren't metal, I'm going to put in another sense. I'm going to call them non-metallic. So I can put these guys over here, I can put these guys, I can put these guys over here, that guy, right? And then I can put a couple of these guys over here, right? Because all these don't look like metal, right? So pretty easy, right? Pretty straightforward, right? So metallic and non-metallic, right? Now, like if we thought this was really easy, there's another layer here, and it's going to get, you know, not complicated, but there's more, right? I'm going to further subdivide non-metallic, right, by how it reflects light. And I'm going to use these kind of special terms right here. I'm going to use glassy, waxy, and earthy. All right? So when we think of glass, is it kind of shiny? Yeah, it is, right? It kind of reflects light, right? Maybe not so much like these metallic ones, but it does reflect light. Do you think that some of these may be, would you think they would be glassy? Right? And you know what I want you to do? I want you to pick them up. Because when you pick them up and you hold them and you go like this, right, then you can start to see how it reflects the light. So I want you to pick some of these up, just like that, just like I'm doing, right? You don't want to go like this, right? Just go like that so it reflects some of the light. And try to tell me which ones do you think look kind of glassy.
This one looks like glassy.
Okay.
This one's like...
All right, there you go.
This one.
Okay. Let's hold up these two guys. This one. All right, let's hold up this one. That one's not, that one's close. Right, can everybody see that as I kind of turn this into the light, right? Do you see that kind of shine to it?
Yeah.
Do you see how it's kind of reflecting light and you can see that? Where it looks kind of like glass would, right? All right, because these guys are glassy, so very good. You guys spotted those out real quick. All right. Now, if it reflects light in a different way, not as much as glassy, so it doesn't look as shiny, all right, we're going to go down to something called waxy. All right, so almost think of like a candle, right, and what wax looks like, because wax kind of can have a little bit of a sheen to it, all right? Which one do you think is kind of waxy? So maybe not as shiny as this glassy one would be, maybe a little bit less than that. Right, which one do we think?
This one.
All right. Let's see, maybe about like this guy. All right, so let's hold up these guys. All right, can we see that they still reflect, all right, a little bit of light there? All right, but not as much as these. And not as much as those, right? Kind of almost like a step down, all right? And remember, we're still all in non-metallic here, all right? So now this last one here is like earthy, or we kind of refer to it as dull, because it doesn't really, the way the light comes off it, it doesn't look very shiny at all. So which one do you think that one would be.
These two?
Yeah, these guys definitely, right? Do you see how if I turn that, like I don't see any kind of shine. All right, see that? I don't really see any kind of shine. So, okay, so like quick recap. All right, we've got color that we've already talked about, right? And it is, we know what it is, and we know that it's the least reliable because we have different opinions and minerals can be different colors, right? The same mineral can be different colors, right? And we can all have a different opinion about it. We talked about luster. We've divided it up into two groups, metallic and non-metallic, right? What do the metallic ones look like? Metal, exactly. And the non-metallic ones don't look like metal. And then we have kind of like a variation in terms of how they reflect light. All right? Some are a little bit more shiny than others. Okay. Now the last one that we're going to talk about, and I'm going to move these guys out of the way, still want them to be visible, is something called streak. All right, so I'm going to go ahead and put this up here. We'll go ahead and read the definition. The color of a mineral in powder form. All right, so the tool that we use for this is an unglazed porcelain plate. So I'm going to give everybody one of these. Great, we got 4 of them. All right. So the only way that we can get this mineral into powdered form is to actually rub it on the streak plate, right? And you may think, oh, okay, well, it's going to be the same color. But actually, in some cases, it's not. So it becomes a really unique feature for some minerals. All right, so let's go ahead. I want you to each grab one of these minerals, and I want you to go ahead and rub it along the streak plate. All right, stop. Okay, what color is the streak of your mineral?
Mine is white.
Mine, is it white?
Yeah.
Oh, all right. All right, and mine was white too, as you can see right here. There's the mineral in its powdered form, and here's the mineral. Good, Mr. Baldwin. Right, and then over here we have the color of the mineral.
Brown.
Right, yeah, kind of like that reddish brown, right? And then we have the color of the streak. All right.
Mine is yellow.
Yours is yellow.
Yep.
There you go. Perfect. All right, so now let's go ahead and I want you to grab another mineral, all right, and go ahead and find out what its streak is. I want you to grab this guy right here. All right, grab another one. All right, stop. All right, so let's go ahead and see. All right, here, yours came out,
Brown.
yeah, like a brownish color. Mine was white again, right there. All right, Potter, let's see what yours.
Mine is silver. It's right here. Mine is brown. Right here.
Huh. All right, well, that's interesting. Why is that unique? Look at that. Does the color of the mineral in its powdered form look like the color of the mineral? No, it doesn't, right? Well, that's kind of unique, wouldn't it be? Right? So not all the time are you going to have the powdered form of the mineral be the same color, right, as the streak.
Today we're going to talk about fracture, and we're going to talk about mineral cleavage. All right? The first one that we're going to talk about is we're going to talk about fracture. And what we're looking at is we're looking at when a mineral breaks, how does it break? Does it break in a regular pattern that we can identify? Or does it just kind of break into something that's very random in shape? So we're going to spend time looking at the shape of the mineral crystals that we can see. Now, it's really important to recognize that some minerals that we have in lab are not really excellent quality specimens. They're not the kinds of things that you would go see if you went to the Smithsonian Institution or if you went to somebody's collection that collects minerals. So there's a difference between lab specimens that we're going to work with and some of the other specimens that are like more perfect. They were grown under more perfect conditions. So let's take a look at what we have here on the table and pick out, each one of you guys maybe pick out one mineral that you think looks like it was really formed perfectly. What do you think?
Yes.
Yeah?
One.
No.
Is there another one?
That one looks good. Take your time.
This one?
Yeah, you like that one too?
Yeah.
Okay, what is it about those that makes you think that those are really perfect minerals?
The smoothness. Yeah. Looks like a perfect rectangle.
Okay.
Yeah, it's cut.
Ah,
It's perfect symmetry.
that's a good thing to say. So were these minerals cut, or did they grow this way in the earth?
They were cut.
No.
Perfect.
They actually grew that way in the earth. They grew under really ideal conditions. They took a long time to grow, but the conditions were just perfect for them to form exactly according to the structures that they should form based on the chemical composition. So we have perfect cubes for some of these, and we have this perfect octahedron.
How long do you think this took to grow?
I don't know. It could be millions and millions of years. A really long time. Okay? So those are minerals that we're going to talk about in terms of their cleavage. Now let's pick some that we think look really random in terms of their shape. They don't seem to have any particular form. That would have fallen apart on you.
That too.
Okay. So this one looks more random than this, and yet these are the same mineral. So this one we're going to talk about fracture. This one we'll talk about cleavage. You have another one over here. Really random. Do you see any straight sides on there? Flat faces?
No.
No, right?
No.
It looks like you could just take a hammer and hit it and it might break into a lot of pieces, but they would all be very random. Okay? And that's really what fracture is. Fracture is when you break a mineral, or when a mineral breaks, it doesn't have any regular repeating pattern that it breaks into. It's random. Okay? So that's one definition that we need to know. Fracture. Random breakage patterns. No real perfect flat straight sides. So flat straight sides here, flat straight sides here, flat straight sides here. On these minerals, those are not fracture, but these are fracture. Okay, what about that one? What do you think? Does that look random or does that look regular? You see flat sides.
On the bottom, I see.
That's
Like,
yeah.
you kind of. Inside. It's kind of. I don't know.
Is it kind of flat or is it really flat and smooth?
It's
Kind of.
Okay. So that's still fracture.
Okay.
All right, and that's a good thing to remember. Even in some of the smaller specimens, like, how about this one?
Yeah, there's a lot of bumpiness.
A lot of bumpiness to the sides, right?
Yeah.
So that would be considered fracture as well. Okay. Let's move on and let's talk about cleavage. So here we have the definition of cleavage. Cleavage is the tendency of a mineral to break along planes of weakness in the bonding structure. So we could talk about the crystal structure, the internal arrangement of all the atoms if we wanted to. And what we would find out is that atoms are arranged in a pattern where there are some weaknesses. And the way that they're weak shows up in the cleavage, shows up where they break. So for example, with these particular minerals, these two, I could take these and I don't want to destroy this one, but I could peel off very thin layers. I could take this and I could peel off layers of this. Okay? They're sheets, right? They're very thin and they're very flaky. So grab that one and see if you can do the same thing with that. See if you can peel off a layer. Get your fingernail under there. All right, there you go. You know what you just did?
I just peeled it off.
You just broke a bunch of bonds. And it broke just the way this black version of that same mineral broke, along that same plane of weakness. So here you can see the weakness, the weak plane is this way. The weak plane here is this way. That's why you can peel them off. Okay? We need to talk about the numbers of directions of cleavage because that's how we identify cleavage. So in these two, this one and this one, these are almost the same mineral. They're in the same family. They're what we call a sheet structure, and they have one direction of cleavage. one plane that is weak. All right? And the way to identify that, whether it's a big piece like this, or whether it's a really small little flake like this, is to take your fingers and see if you can find those perfectly flat faces. So pick this up, find those two perfectly flat faces, the top and the bottom. You guys can grab those, grab a little piece of it, or grab one of the big ones. Hold it between your index finger and your thumb. The top and the bottom. Are those two perfectly flat faces parallel to each other?
Yes.
Yeah.
Yeah.
Yeah? Okay, so what you're looking at here is you're looking at a structure. The internal arrangement of the atoms is lots and lots of sheets, just like a stack of sheets of paper. And it doesn't really matter whether you're looking at the top sheet or the 50th sheet or the 10,000th sheet. You're always going to be able to stick it between your two fingers, and that's one direction of cleavage. Okay? So one direction of cleavage here, one direction of cleavage here. You see the single one direction of cleavage on each of these little itty-bitty flakes, and you could keep peeling those off into really, really fine sheets until you got down to the point where you have one layer of atoms thick. Okay? You could do that. So that's one direction of cleavage. What do you think two directions of cleavage would be if that's one? Kind of tough question. All right, let's take a look at this one. And why don't you pick it up, one of you, and see if you can find parallel sets of faces.
Would be this top and right here.
Okay, so you got a top and a bottom.
Sides. Maybe the sides or something?
Okay, so show me. Use both hands and show me top and bottom and maybe...
Oh, it's like this.
Perfect. All right, so you've got the top and the bottom and the front and the back, right?
Yeah.
Two sets of parallel faces. If we took a hammer and we hit that mineral with a hammer, it would break into smaller chunks that all have two directions of cleavage. What about the ends on that one? What about this end here and this end here? Take a look at those and see if they look the same or if they look different in any way to the other faces that you said were parallel. You might, go ahead.
Looks different because like one is like smooth,
Uh-huh.
the other one's like kind of open.
Okay. Remember in the last video we were talking about luster? The way light is reflected from the surface of the mineral? Look at the ends and see if it has the same luster on the ends as it does on the cleavage faces.
It doesn't.
It doesn't? Is it, how is it different?
Because the parallel sides are all a little bit more shiny, and then the other side, two sides are not.
Okay, so the parallel sides would be non-metallic and glassy, okay? And the ends are a little bit more towards the waxy or the dull side. So that's another way you can tell that has two directions of cleavage. Okay? All right, three directions of cleavage. So we're going to look at something like this. We've got these nice wooden models that we can look at, and something like this. So grab those. Whoops, we don't want to look at that one. It's got funny ends. Grab that one, and why don't you guys take one of those and see if you can identify the three directions of cleavage there.
There's 1, 2, and then 3.
So, no, 1, 2, no, 1, 2, 3.
Perfect. So do it again. You got
1,
the top and the bottom,
2,
the two sides,
3.
and the front and the back. Okay, and on the cubes,
Top
top and bottom.
These two sides and then right here.
Perfect.
Front and the back.
Okay. So that's three directions of cleavage. Now let's look at the angle between, say, the top and the front side. What would you say the angle is between the top and the front side?
It's a right angle.
Same thing on those cubes?
Mhm.
Okay, it's a right angle, right?
Right.
Okay. Now I want you guys to take a look at this one and see if you can find the three directions of cleavage on that one also.
So like these two,
Okay?
these two
Perfect.
and the
Top
these
bottom.
two. Yeah, top
All right,
bottom.
so you found the top, bottom, front, back, and left and right sides. But how is this specimen different from these?
The shape is kind of different. Angles?
Yeah. So the angle on this one is right angles. Is that right angles?
No.
No. But does it still have 3 directions of cleavage?
Yeah.
Okay, so we have 3 directions of cleavage in cubic, or 3 directions of cleavage at right angles or at 90 degrees. And on this one, we have 3 directions of cleavage not at 90 degrees. And this is actually called rhombohedral. Okay? But still 3 directions of cleavage. Again, with this specimen, if we were to take hammer and hit it and break it up, we would have lots and lots of little rhombohedra that would break off. 3 directions of cleavage, they would just look like that squashed box. Okay? So that's 3 directions of cleavage. We talked about 1, we talked about 2, and we talked about 3. When we see mineral specimens, lots of times mineral specimens with low amounts of cleavage, 1 direction, 2 directions, or 3 directions, they actually grow pretty readily. So we'll pick up a rock when we're out looking around at rocks, and we can find minerals that show that cleavage. When we get into the higher levels of cleavage, you have to go for the fancier specimens, and you don't find them very often because the conditions they need to grow under are not always found. So they're rarer and rarer and rarer. We have a couple examples here of higher amounts of cleavage. But before we look at that, I want to just look at the book a little bit for a second. So when you're in lab and you're practicing your determination of the physical properties, you're going to be using this book, and this is going to be a page you're going to love to have available to you. Okay. So let's take the pictures here, and let's see if we can match up a couple of these specimens to these pictures that are shown here. So this shows fracture, and it shows cleavage. Can you find specimens that match up to those pictures?
This one's that one.
Perfect. So
This would
that's
be
fracture.
Like right here. Like part of that one or no?
What do you think? See how the ends are rough here?
Oh, so it's
Which one did we say had rough ends?
this one.
Great. Okay. Where do these go? Beautiful.
Right here.
Yeah. And what about our little flakes, our little one directions? Where do they go?
They'll go like right here.
Okay, so you can see how when you're in the lab and you're trying to identify cleavage for minerals, you can take the specimens and stick them right there on the book.
Right.
And that will help you out with identifying them. So this particular one, which is a mineral that's called fluorite, and the interesting thing about this for us is it's the state mineral of Illinois. You all knew that, right?
Yeah.
Just like cardinals are the state bird, fluorite is the state mineral. It comes in lots of different colors, and this is the perfect shape for it. And this one has 4 directions of cleavage. I'm going to challenge you. Can you find the 4 directions of cleavage for me? You might need to borrow a hand from across the table, too. Let's see if you can do it.
So that's 1, 2, 3, and 4? No?
What do you think? Are you looking for parallel sides?
Yeah, maybe. Yeah.
That's what you want to look for, is you want to try to put your fingers on the parallel sides, just like this. These 2 sides are parallel.
Am I looking for parallel sides?
Uh-huh.
Right? Yeah.
So is this side parallel to that side?
Yeah. That's,
Okay,
Yeah.
good.
And then there's these.
You got it.
And then. Yeah.
Those 2, and then the
Yeah.
other 2 that we don't have our fingers on, okay? Lots of
Yeah.
fingers in there.
Okay.
Okay? So that's the 4 directions of cleavage. Even though it has 1, 2, 3, 4, 8 faces on it, it has 4 directions of cleavage, okay? The last one that I want to show you really, really quickly, and this is very uncommon, is this one right here, which is called a dodecahedron. It has 12 sides, and it has 6 directions of cleavage. That particular crystal is a crystal of garnet. It probably took several million years for that crystal to grow under really perfect conditions, and it grows those beautiful 12 sides. We won't see things like that in lab, but they're really nice when we can't see them.
Definition. So if we take a look, the hardness, it's simply the resistance of a mineral to scratching. Okay, so we want to see how easily or how difficult it is for something to be scratched. We use a couple tools. We use some easy stuff like our fingernails, and we use pennies, and we use these glass plates, and we use our streak plates from before. and then some nails or files. Okay? So I'm going to ask you guys, which one do you think is the softest out of this group? So we've got fingernails, pennies, glass, nails, or streak plate. Which one's the softest?
The plate.
Think the plate's the softest? So the easiest to scratch?
Maybe. No, the glass.
Glass is easiest to scratch.
Maybe.
Maybe, okay. Well, how would we figure out which one's harder, my fingernail or the glass? How can we figure out which one's harder?
Scratch it.
Scratch it, right? Okay. Let me get a nice black background for you here. So, I can take my fingernail. Luckily, I just got my nails did. So, does it look like my fingernail is scratching that glass?
No.
No, and that would be a bad thing if my fingernails could scratch glass, because if I did that on a window, it would be I'd be breaking the glass. Now, how could I figure out if the glass is harder than my fingernail?
Scratch your nail.
Try and scratch my nail, okay? So make sure you don't get your nails did right before this. But if you take a look, describe what's happening to my fingernail. Do you guys see what I'm doing?
It's getting streaked.
Yeah, it's kind of streaking, right? Okay, so what am I breaking? Am I breaking my fingernail or am I breaking the glass?
Your nail.
Breaking my nail, right? So which one's harder, the glass or my nail?
The glass.
The glass is harder, okay? So that basic way of doing that is how we're going to figure out the hardness for each of these, okay? So let's say I took this streak plate and this glass. Which one do you think is harder? Plate? Okay, so how can I figure this out?
Scratching it.
Okay. Is it breaking the glass? Okay, so one way we can test too is we can take the streak plate and we can try and make a nice little scratch. I hope you can see it on the camera. What do you see on the glass plate?
Scratch.
Little scratches, right? So which one's harder, streak plate or the glass?
The glaze. Plate.
Yo, the plate.
Why is the plate harder? You're right.
Because
It scratches the glass.
Because it scratches the glass. Okay, that's like the basic property we need. Whatever scratches the other thing is going to be harder. Okay? So let's start looking at some minerals first. Okay, let's start, I think, with this one. Okay? Take a feel of it. Do you think it's a really hard or a really soft mineral? Just getting to know her mineral.
Soft.
It's very soft. Oh, it's like falling apart on the table, right?
Oh, yeah.
Okay, so do you think your fingernail is going to be able to scratch it?
Yeah.
Yeah?
Oh no.
You broke it. What'd you do?
Oh, my nail's harder than this mineral.
Absolutely. So your nail's harder than this mineral. So what we can do is we can use that to help give this a number. Okay? So if we take a look at our lab manuals again, this is going to be a really useful tool for us. We're using a scale called the Mohs scale of hardness. So all it is each of these tools that we have. So our fingernails, the pennies, the streak plates, the glass plates, the nails, and the file. All of them have a set number. So like, if we look on our piece of paper over here, what is the hardness of our fingernail?
2.5.
2.5, okay? So, is our number going to be higher or lower than 2.5?
For the mineral?
Yeah.
Lower.
Lower, good. So I know that this hardness of this mineral is going to be lower than 2.5. Okay? Ready for another one?
Mm-hmm.
Okay, so let's try this one. Abby, you got this one. Alright, so does it feel hard or soft?
Hard.
Kind of hard, right?
Mm-hmm.
Do you think you can scratch it with your fingernail?
A little bit.
A little bit. So is the mineral breaking?
I mean, there's powder.
It's powdering, right?
Yeah.
Okay, so what's harder, fingernail or the mineral?
The mineral.
The mineral. Good. So now, both of these... Oh, sorry. I just did that backwards. Yeah, you're right. The fingernail should be harder. Okay? Because it's scratching the mineral, right?
Yeah.
Okay, sorry. Miss Lawai just gave me a really funny look from behind the camera. Okay? So now, I've got two minerals that are softer than the fingernail. How do you think I could figure out which one's softer than the other one?
Scratch it against each other.
Oh my gosh, that's awesome. Try it out. See which one's softer.
Ooh. Well, isn't it pretty obvious if you know that this one's softer than the nail and then this one's harder, then this one's going to be softer than this mineral?
Okay. Cool. So that one's breaking this one, so we know that this mineral is softer. Okay? Let's do another example. How about you walk us through this one?
That's harder.
Okay, so it's mineral's harder than your fingernail. So I know it's greater than 2.5. what should I use next on the list?
Penny.
Good. So take a penny.
It's a little bit powder.
Okay, so a little bit powder. One of the best ways you can do this too, if you're not quite sure, try and find a pointy edge on the mineral. So like here's a nice pointy edge, and find a nice soft spot or flat spot on the penny. Did you see what happened to my penny there?
Yeah.
Yeah, it scratched it, right?
Mhm.
So the mineral's harder. Okay, so what should I go to next on my table? Skip the brass, we don't have the brass.
Nail.
Yeah, so we'll take an iron nail. So what's being scratched?
Mineral.
The mineral's being scratched. So, based on that, we know it's softer than a nail, but harder than a penny. So let's look to our table here. What's going to be the hardness?
4.
Okay, so I just know it's softer than the nail, but harder than the penny. So I'm just going to estimate it's between 2.9 and 4.5. We give it a range, because we're not exactly sure if it's 4, if it's 3.2, somewhere in the middle. Okay? Should we do another one? Alright, let's go with this one. You got this one.
Alright. So first my nail, right?
Mm-hmm.
Alright, the mineral's harder, and then the penny.
And the penny.
The mineral's still harder. And
Mineral's-
then the nail, right?
Then the nail, yeah.
And the mineral's still harder.
Still harder. So what do we do after the mineral? Or sorry, the nail. Okay.
The glass.
Could do the glass, yeah. Be careful with the glass too. You don't want to go shattering pieces all over.
Alright, it's kind of deteriorating a little.
What's it? The mineral or the glass?
The mineral.
Okay, well let's take a look. One of the best ways to do it.
Wait, no. Just kidding. It's the
Ooh.
glass.
Oh my gosh. And if you're ever not sure, try it the other way. So take the mineral and try and scratch the glass. Okay, and you should see that little scratch mark in there. Okay. So if I know the mineral is harder than the glass, what should I go to next?
Streak plate.
Streak plate. So see if it scratches the streak plate.
Is this
Mhm.
one? Okay. Do we do it this way or I'll just try it?
What do you think? You tell us, you've got it.
I think it's the plate is deteriorating.
Okay, so the plate's deteriorating?
Yeah.
Okay, so again, if you're never quite sure, one of the best ways is just put the plate on the ground and try and break it. And you should feel kind of a little bit of like a groove in there because you're breaking the streak plate. And this one, you're actually deteriorating or you're breaking some of this mineral. So this should be harder than the streak plate. Okay? Oh, sorry, did I just say that backwards again? Oh my gosh, I'm so bad. So, the mineral should be softer because the mineral's breaking down. Okay? So, I know that it scratched the glass, but it didn't scratch the streak plate. So it'll be between 6.5 and 5.5. Okay?